You guys just saw a demonstration where we dropped a piece of paper that was all crumpled up in a set of keys, and you saw that they hit the ground at essentially the same time. The reason they did that is because when we crumpled up that piece of paper, we effectively took away its air resistance. The air resistance of the keys and the air resistance of the paper were basically the same. And in the absence of air resistance, or when air resistance is the same, then all objects will end up falling at exactly the same rate. Even a piece of paper and a set of keys will fall at the same rate. All falling objects. You guys saw in the video just a second ago that on the moon, a hammer and a feather fell at exactly the same rate. In the absence of air resistance, all falling objects will fall at a rate of exactly negative 9.81 meters per second squared. I say here, under the influence of only gravity, in other words, not under the influence of air resistance, will fall at a rate of negative 9.81. Now, that rate of acceleration, negative 9.81, is a little bit different depending upon where you are on the Earth. Okay, when we're closer to sea level, that value is a little bit bigger. When you're higher up, that value is a little bit smaller. If you were to go to a mountain in Banff, then you would find that that rate would decrease, but not very much, like very, very small difference. You'd find on Earth, the range would probably be from about 9.76 or so to about 9.83 or so. Right? We're talking about somewhere like New Orleans, which is below sea level, to the top of Mount Everest. Right? Very, very small difference. But in one particular place, where maybe the acceleration is negative 9.81, which is about an average, every object in the absence of air resistance will fall at that rate. Now, even though it is a little bit different everywhere on Earth, that's the number that we're going to end up using. Doesn't matter where we are on Earth, that's the number we're going to end up using. Now, if falling objects accelerate at negative 9.81, then objects that are rising, going up into the air, because I threw them up into the air, will also accelerate at a rate of negative 9.81. Why is that the case? Well, because they experience the same force as objects that are falling do, gravity. It's the same thing that causes it. It's the same object. It's going to have the same result. So, as this board marker falls down towards the floor, it speeds up at 9.81. Therefore, because it's speeding up in the negative direction, the downward direction, we'll call it a negative 9.81 acceleration. But as if I throw this board marker up into the air, it will slow down at a rate of 9.81. We'll call that a negative 9.81 again, because it's slowing down in the positive direction. Does that make sense? So when you're speeding up in the negative direction or slowing down in the positive direction, the acceleration would be negative in both cases, and that's why, regardless of whether the board marker is falling or rising, we'd say its acceleration, in the absence of air resistance, is negative 9.81 meters per second squared. Listen, that might be a little bit confusing, that the acceleration is exactly the same whether you're slowing down upwards or speeding up downwards, but in the end, it makes questions easier. It's a good thing that it's the same acceleration, because we don't have to worry about using two different values in two different times. If an object is just moving through the air, its acceleration will be negative 9.81 regardless of what's happening to it, up or down. It's the case with any other acceleration, by the way, as well. Right? Any other acceleration, horizontal acceleration, if you slow down in the positive direction, that's a negative acceleration. If you speed up in the negative direction, that's a negative acceleration. Right? Slow down as you're going to the north, or speed up when you're going to the south. In either case, that's a negative acceleration. We're going to do a few problems today involving gravitational acceleration. I want you to understand that when we do these problems, there is almost no difference between these ones and the ones we've been doing over the last couple of days. It's more acceleration. It's the reason we're doing it right now, is because it gives you more practice on acceleration. But the one small difference is that you have an additional given, an additional thing provided to you that is usually one of those read between the lines givens. One that it doesn't say specifically, you just have to kind of read the question and kind of understand that even though it doesn't overtly say it, this is given to you. That extra given is A is equal to negative 9.81 meters per second squared, unless there's some other force other than gravity. Okay, if there's something in addition to gravity acting, then all bets are off. But if it's just gravity, then we know that A will be negative 9.81, whether it's going up or going down. So let's take a look at the first question, which is from your textbook again on page 57. It says, while cliff diving in Mexico, a diver throws a smooth, round rock straight down with an initial speed of 4 meters per second. The rock takes 2.5 seconds to land in the water. How high is the cliff? All right. So what do we do here? What do we got given to us? Well, we know this is a group B problem, right? Because this rock accelerates as it falls down from the top of this cliff down to the water here. So it's a group B problem, right? What are we given here besides knowing that it's a group B problem? Something is 4 meters per second. 4 meters per second, right? Something is 2.50 seconds. I'm going to call that the time, actually. What's the 4.00 meters per second? That's a speed or a velocity, right? Initial or final? Or average or change or what? Yeah. Yeah, it's going to be my initial. Now, it actually says initial speed of 4 meters per second. I don't want to do that. Listen, I know that it's thrown downward at 4. We know more than the speed of this rock, right? We know the velocity of this rock is negative 4 because they tell me it was thrown downward, not thrown upward. So why not include that? If we didn't know that, if they didn't tell me that, all right, that's fine. Then we'd have to say the speed is 4. But if they tell me what the direction is, that it's thrown downward, then why not include it? What are we looking for? How high is the cliff? What is that? Yeah, I mean, technically it's like a height, right? An h. But really, if we find the distance that the rock traveled or the displacement of the rock, then that's going to give me the height of the cliff, right? Because the rock fell or was displaced by the height of the cliff. So let's look for displacement here. And that's going to be the same thing as the height of the cliff. Is there anything else we have if we read between the lines here? Yep, JC? Yeah, what's the acceleration? Right. Now, I don't want you to blindly make acceleration negative 9.81. Like, look at the question, read the question, and understand that if it's moving horizontally, that's not going to be the case, or at least not likely. If it's moving up or down, it could be the case. If it's moving up or down in the absence of any other forces other than gravity, so if it's just gravity moving up or down, then the acceleration will be negative 9.81, like it is here. Okay, so what are we going to do here? VIT, looking for D, got A? Probably going to try this one, right? Is equal to VIT plus 1/2 AT squared? Look, this question isn't any different than the ones we've been working on for the last couple of days. Now that we recognize A is negative 9.81, VI is negative 4.00. If we're going to use this equation, it's important to know that that's negative. Because if you make it a positive, you're going to get a completely different answer. T is 2.50. A is negative 9.81. You can imagine here if I had positive 4 and negative 9.81, again, my answer is going to be completely different than what I get here. All right, let's do this on the calculator up here so we can see exactly how to enter this here. Let's say negative 4 times 2.5 gives me, whoops, turn it on first. Let's say negative 4 times 2.5 gives me 10. Negative 10. Plus, what's the next one here? Let's say 0.5 times negative 9.81 times 2.5 squared gives me negative 30.656. We add those up. We don't need to use our calculator for this. We get negative 40.656 meters, which we're going to round to how many digits? Our data is both 3 digits, including 9.81 is 3 digits. Our final answer will be 3 digits, right? So we're going to round that to 40.7 meters. Now, is the height really negative 40.7 meters? No, really the displacement of the rock is negative 40.7 meters. What's the height? Positive 40.7 meters, right? But if you left it as negative 40.7, I'm not going to mark that wrong. Like, that'd be fine. But in the end, strictly speaking, the height is 40.7 meters. Now, that's a pretty high cliff that you're jumping off of, right? 40 meters. 40 meters. That's half a football field high. You got to be pretty careful if you're jumping off a cliff that's 40 meters high. Like, there's a real danger of killing yourself when you're jumping off a cliff that high. How come? Like, what's the problem? It's water, right? Can't you jump off of any height into water? Yeah. I mean, the surface tension of water. You guys learned about surface tension, I think, in Science 10, right? And you learn in Science 10, I think, that the surface tension of water is quite high. It has very high surface tension. If you're moving that fast when you hit the water with that surface tension, unless you hit it perfectly, like, watch out. If you're going to hit it from 40 meters high, you don't want to have any surface area at all going into it, right? So you want to do a perfect pencil dive or perfect, like, head first, but perfectly like this, right? You don't want to have your arms out, or it'll probably rip them right off almost, right? Certainly take them out of their sockets because of the surface area, or the surface tension, I should say. All right. So let's have a look at these 3 questions, please. Keeping in mind they're pretty much the same as you've been doing the last couple of days, except that they involve gravity. Now, again, don't blindly assume A is negative 9.81 meters per second squared. Just look at it and say, okay, is it moving up or down? And if it is it just gravity? And if it is just gravity, then make it negative 9.81. If there's something else acting as well, then you got to come up with a new acceleration. All right, let's give it a try here. We're going to have a look at number 1. It says if a rock takes 0.75 seconds to hit the ground after being thrown down from a height of 4.8 meters, determine the rock's initial velocity. What do we got here? We know that it's a group B problem, right? As I was walking around here, watching you guys do your work, I saw a few people, actually, more than one, say V equals D over T for this. Use a group A equation. Okay, listen, even if it fits the givens, we can't use that. We know we can't use that because that's valid only when you have constant or average velocity. This is acceleration. We've got to use group B, which are those 5 equations that I taught you a couple days ago. So we're going to say for this, delta T is equal to 0.750 seconds. We're going to say that my displacement, the displacement of this rock, is negative 4.80 meters because it ends up 4.8 meters below where it started. Somebody said, does that make the height negative? No, the height is 4.8 meters, but the displacement of the rock is negative 4.8 because it falls from the height to the ground. We're looking for VI. We do know the acceleration here is negative 9.81 meters per second squared as well. Now, somebody else, as I was walking around, asked me what I thought was another really good question, actually. Since we're throwing it downward, does that mean the acceleration is different? No. Once it leaves my hand has no control over it, right? It's just gravity acting then. Once it leaves my hand, gravity pulls it down at negative 9.81. It doesn't matter how hard I threw it. Okay, once it's gone out of my hand, it's just the Earth pulling on it. And the Earth doesn't pull on it differently because I threw it versus me dropping it. So regardless of how fast it's moving or being thrown or dropped or whatever, the acceleration once it leaves my hand is negative 9.81. Whoops. VI is not negative 9.81. A is negative 9.81, right? Make sense? We're looking for VI, right? We're looking for VI here. Does that make sense? Throw it, drop it, doesn't matter. If I drop it, VI will be 0. If I throw it, VI will be something, but A will still be negative 9.81. Now, as I was saying, a number of people were trying this. V is equal to delta D over delta T. And why were they doing that? Hey, look, it almost makes sense, right? Because I got d, I've got delta t, it fits, but it's wrong. It's wrong because this is a problem that involves acceleration. So I cannot ever use that equation in this context. Rather, I'm going to try this equation, d is equal to vit plus 1/2 at squared. Now I got to solve for vi here. This is tricky, but we've done this. Get rid of what is not attached. Okay, what is not attached? Yeah, Jack. Good. 1/2 at squared. It's added to vit, so I'm going to take it over by, good. We're going to say d minus 1/2 at squared equals vi times t. Now, I got to get rid of a t because it is attached, and it's multiplied by vi, so I'm going to take it over by doing the opposite, which is like dividing, right? Now, this is going to look a little ugly, but that's okay. D minus 1/2 at squared divided by t. Everything on the left side divided by t. So let's sub our numbers in here now, okay? D is negative 4.80. Subtract 1/2 of negative 9.81 times 0.750 squared divided by 0.750. Some of you might think I can cancel out a time here because it's on the top and the bottom, but I can't because it's not in every term on the top. So you got to leave it there. Okay, let's work through this as a group here. Let's say negative 4.8 subtract, and then let's put that whole term 1/2 at squared in brackets. Subtract bracket 0.5 times neg 9.81 times 0.75 squared, end bracket. See what I've done there? Right, negative 4.8 subtract everything that's on the right-hand side there. All inside of the brackets. Now let's press equals, and then let's divide that by 0.75 seconds. Gives me negative 2.72. We should be 3 digits here, right? This is 3, this is 3, 9.81 is 3, final answer should be 3 digits. Should it have been a negative value? The question says the rock was thrown down. The rock was thrown downward. That means the initial velocity should be negative. We don't have to force it to be negative. Okay, the beauty of mathematics is that when something's supposed to be negative, it'll just happen. It'll just work out to be negative. It's a nice little check, right? If you get a positive answer for this, you know you've made a mistake because it was thrown down. Right. Make sense? Okay, let's keep working on 2 and 3 here. And then we'll take a look at one of those here in a few minutes if we need. Let's have a look at number 2 here and go through the challenge of this one, because this one does seem pretty challenging to me here. Having scored a touchdown, a football player spikes the ball in the end zone. The ball was thrown down with an initial velocity of 2.0. We're going to say that VI is negative 2.0. As I was walking around, I noticed a lot of you just made it positive. It's got to be negative because it's thrown downwards. We know that the displacement is, well, it's negative 1.75, not 1.75, but negative because it ends up below where it started. We know that the acceleration is negative 9.81 meters per second squared, and we want to find out the time. Now, the temptation of this, my temptation even when I was looking at this question at first, was to say d is equal to VIT plus 1/2 AT squared. Whoops, that's not what it is. Right, I got D, I got VI, I got A. The only thing I don't have here is T. The only problem is it appears in 2 places. That is a problem. Unless you've learned in math class something called the quadratic equation, and most of you probably have not by this point. If you're in grade 12, you probably have. But in grade 11, most of you will not have learned this yet. Unless you've learned that, you can't do this. Okay, you can't use that equation to solve for T. It's impossible. The only other option we have is to use some other equation to get something else. Like maybe VF squared is equal to VI squared plus 2AD. Solve for VF. Now, once we get VF, now we got some options, right? Now we can say, I don't know, D is equal to VI plus VF over 2 times T, right? Because now you have D, VI, and VF now. Did we sub into there? Does that make sense? Be careful, though. With this equation, this is speed, right? So when I sub a number in here for VI, I'll make it positive 2 because I'm not subbing in the velocity, just the speed. A will still be negative, D will still be negative. When I sub that number into here, I got to make it a negative value because I know it's moving downwards at the end. Okay? See what you can do with that. And number 3, okay, that's your homework for tonight, questions 1 to 3. And of course, tomorrow we have a quiz on just regular acceleration, not gravitational acceleration.